Hello everybody.
Hi, I can hear you.
Okay, good. So hello everybody. Thank you for joining us for the webinar. So today I will introduce our 7 to 12 kilowatt hybrid inverter and the working modes, because we have launched this product in the market for about 1 year, and the customers still have some questions on the working modes. So today I will introduce the working modes again to everybody, and also that because before it may be a little bit difficult to do the settings in our monitor system for the working modes. So actually in the past few months, we optimize the setting page website to make it easier to set the working mode for our inverter. So I will show you how to set the inverter's working mode with the new web. So first of all, I will have a brief introduction of our hybrid inverter, and then I will introduce the working modes for the inverter. At last, I will show in our monitoring system, and also I have an inverter beside me to do some setting change. So you can see how the change affect the inverter running. Then let's go to the first part, is the product introduction. For the 7 to 12 kilowatt for the Europe version, now we have 7 kilowatt, 8 kilowatt, 10 kilowatt, and 12 kilowatt, 4 models. And for the 12 kilowatt, since it's already very big, and we also support parallel function, then it means that for this series hybrid inverter, you can both use for residential solution and also the commercial. This is our 12K inverter, and there are some features. So first of all, this is a low voltage battery system, which is very important because there are few brands can go to 12 kilowatt in the market, and with the 48 volts battery, the cost of the whole system is lower than the high voltage battery and is safe. For this inverter, so also you can have some many batteries. You can have your own options for the battery, so it's more flexible. The output of the inverter is 12 kilowatt for backup, which is very big. The discharge current from the battery can be 215 amps. So later I will give some key parameters. Then for this inverter, for this series, we have a separate generator port. With this generator, we can do many functions like smart load control, and also the generator connection, the AC coupling function. So it's a very flexible port. Then at last is a touch screen, is a true color touch screen, and you can use like on your mobile. You can touch and set. Some parameters for the 7, 8, 10, and 12K. So for the 12K, we have 3 MPPTs, 4 strings input. So it's like for MPPT1, MPPT2, we have 1 string, and for MPPT3, we have 2 strings. For the 7 to 10 kilowatt model, we have 2 MPPTs, also with 4 strings. So it's like for 12 kilowatt, if you can have 3 MPPTs, it means that you can have 3 directions when you install the solar panel. And the maximum solar input for the 12K is 18 kilowatt. And the maximum for the 10 kilowatt model is 15 kilowatt solar input. For the battery side, it is working with low voltage battery. So the maximum charge and discharge current for 12K can be 215 amps. And for the 10K, it can be 210 amps. So it's very big. in some situation, when you are using your grid to charge the battery, it need to charge battery and take load together. So you have to know that what is the limitation to AC input to take load and charge the battery. The last one is the generator port. So for the generator, the 12K can support 19 amps input to take load and charge battery. For the 7 to 10 kilowatt, it can be maximum 50 amps input to take load and charge battery. So these are the key parameters for this model. And for the functional, I introduced later, the function is almost the same. So we can see the features like for this 12 kilowatt or 10 kilowatt is outdoor design. So you can install both indoor and outdoor, and the seamless switch also installer friendly. So there is the room is enough for users to set to install the system. And also, sorry for this, APS rapid shutdown, I think is for the US model, not for the Europe model. So for the US, but it's optional. If you want to add the APS rapid shutdown, you can add the rapid shutdown in this unit. The other thing is for parallel function, as mentioned, we support 10 units parallel connection. It means that for 12 kilowatt, you can go to 120 kilowatt. So it's enough for the small commercial system. And also for our unit, you can make it as a single phase or 3-phase. So it depends on the application which you need. Okay. So for the other features is flexibility for the battery connection. You can connect the battery as a big battery bank, or you can connect the battery separately to each inverter. The advantage for this is like when you install one system, later you may want to add more batteries and inverter another because the current is very big. So for if we support the each inverter connect with a separate battery group, then it's easier for installation for the installer to install the system. The time will be shorter and the material will be easy to buy. This is another features of GenPort I mentioned. For the GenPort, we can support smart load function, AC coupling, and also we have smart generator control. In this case, it's a little bit complicated for the users to use. So I will introduce in the next webinar for the generator connection, when you want to use the smart load, how to set, when you want to use AC coupling or use it as generator. So next webinar, I will introduce the generator connection and the settings. Then, as you know that the monitor system is very good from LuxPower. You can see the whole system very clearly, and with the 10 kilowatt or 12 kilowatt, when you are using some bronze battery like Hina battery, you can see the information of each battery module. So it's very easy to do the system maintenance. And then also we have some quick button to start AC charge and or start the generator. So it's very convenient for use our monitor system. The other one is solar panel monitoring. If you are using the micro inverter like or optimizers, we are perfectly working with them. You can log in your system in your like Tego system in our monitor system. Then you can get all the information of the solar panel, and you do not need to go to the Tego's like app to get each information. So one app can let you know the whole system, like the panel information, the inverter information, and just mentioned the battery, each module. So it's very like you can see deeply of the system, what's the system status and what's each module, each battery module, each solar panel status. Yes, that's the brief introduction of our 12 kilowatt, some features. And then we go to the main topic we will discuss today is the working modes. So for the 12K or the 7 to 10 kilowatt inverter, we have working modes as below. Belowing, like we have self-consumption mode, we have charge first mode, peak shaving mode, AC charge mode, and the forced discharge mode. Then I will introduce these working modes one by one. The self-consumption mode is like maybe in other inverters, they call it SBU, because in self-consumption mode, if you do not change anything from the system when you get the inverter from the factory default, it is self-consumption mode. So in this mode, if you have those, it will be use the solar power first. And if solar power is not enough, it will use battery to take the load. At last, it will use the utility. So this is an example for the application one, like this in picture one. There is enough power from the solar, and so the solar will take the load first. And if there is extra, it will go to the battery. Then at last, if you are allowed to feed into the grid, the extra power will feed grid. Then if there is not enough solar in application 2, if there is not enough power from the solar panel, so the battery and the solar will take load together to feed the load. And then if the solar and the battery still not enough, for example, you have 15 kilowatt load and your solar only have 2 kilowatt and your battery can only discharge like 5 kilowatt. So it's still lower than the load demands. Then the utility will take these loads. So for the self-consumption, it will use solar first and then use battery, and at last use utility. The next one is charge first mode. So from the words we can understand, in this mode, you can set enable, and in this enable charge first. Then in this case, the PV, the solar power will charge the battery first. So in self-consumption mode, if there is solar will go to load first. But in charge first mode, solar will go to battery first. And then we can see there are also 3 examples. So for the first one is still, if there is enough solar, the solar will first charge the battery, and if it has extra power, it will take the load, and the last, the solar power will go to the utility. Then how about if the solar is not enough to, for example, is less than the battery request for, can accept. For example, the battery wants 10 kilowatt to charge, but you only have 5 kilowatt solar. So all 5 kilowatt from the solar panel will go to the battery. So that is called charge first. And how then in this situation, because the solar already goes to the battery, then the utility have to take the load. Only when the battery is higher than your charge first SOC stop. So there is a setting. Then, for example, you set charge first SOC stop SOC 90%. Then when the battery SOC is higher than 90%, the solar power will go to the load. And if the power is not enough, the solar power is not enough to take the load, the utility will take the load together. So please notice that in charge first mode because we think it's very important to charge the battery. So in this working modes, we will not discharge the battery. So when you need power, we will use power from the utility. This is different from the self-consumption. In self-consumption mode, we can see here. Then in self-consumption mode, the battery and the PV will take the load together when the solar power is lower than the load. But in self-consumption mode, the power will go from the solar and the utility. The battery will be in a standby mode if the power is the battery SOC is higher than the end charge first SOC. So I can show in our monitor system for example. As an example, the next one is peak shaving. Peak shaving is a little bit complicated than the other working modes. It's used in the application like when you, for example, the utility, the power company allow you to use 10 kilowatt from the grid. If you are using 12 kilowatt, then the extra 2 kilowatt, the cost will be much higher than the first level, like the 10 kilowatt. So you have to pay extra money for the higher demand from the utility. So in this situation, customer can enable peak shaving function. This has some application in America, and for the South Africa market or other Europe market, it's not very popular. I think it's not very popular as in America. But I can introduce a little bit for this. This is like the idea is, for example, you can set for the peak shaving function, you can set peak shaving SOC. Then when the SOC is lower than the peak shaving SOC and higher than on-grid SOC, the inverter will in peak shaving mode. For example, here we set peak shaving SOC 80% and on-grid cutoff SOC 20%. So when SOC is between 20 to 80, the inverter will be in, and also you need to set the periods for peak shaving. So during the period, if the SOC is in this range, then it will go to the peak shaving mode. So here we set peak shaving power to 15 kilowatt. Then it means that you can maximum get 15 kilowatt from the grid, and you need to avoid high demand. So for example, if during the peak shaving mode, if you have power larger than 15 kilowatt, for example, you have 18 kilowatt, then the battery will discharge 3 kilowatt to avoid you using too much power from the utility. When you have like 10 kilowatt is lower than the 15 kilowatt, then it will use 5 kilowatt to charge the battery in case so it's like once it finds the chance to charge battery, it will charge the battery in case later you have large load, then it's prepared to discharge. This is an example. For example, the SOC is from 10% here, and the load is 10 kilowatt. And then you can see that since the load is lower than 15 kilowatt, then we can charge 5 kilowatt from the utility. Then we will charge until here, charge for example, SOC to like 40%. And when it goes to 25, the on-grid SOC when charge is higher than on-grid SOC plus 5%, it enters the peak shaving mode. So in the peak shaving mode, then 10 kilowatt is lower than the 15 kilowatt. We can still charge with 5 kilowatt. So the SOC keep increasing. And then at this time, the load goes to 20 kilowatt. So we can see 20 kilowatt is higher than 15 kilowatt. There are we need to compensate 5 kilowatt from the battery and to avoid using too much power from the utility. So in this situation, we will discharge, sorry, this is discharge 5 kilowatt, and the battery will goes down until the on-grid cut off SOC. So when it goes to 20%, it will stop discharging and in a standby here until the load is lower again. So here the load changed to 5 kilowatt, and since the peak shaving power is 15 kilowatt, we can use 10 kilowatt to charge the battery again. So it will increase, keep charging until the SOC is higher than the peak shaving SOC plus 5% in here. Then it enters to self-consumption mode. So we can see here, when SOC is increased, when the SOC is higher than peak shaving plus 5%, it will be in self-consumption mode. So because in the self-consumption mode, we think there is enough battery energy in the battery, so we can compensate the whole load. For example, here, if you have 5 kilowatt load, so we will discharge the battery 5 kilowatt to compensate all your load to avoid using any power from the battery. So in self-consumption mode, we will try to not using power from the battery. Okay. So when the SOC is larger, when you think there is enough energy, then it will be in a self-consumption mode. So the discharge power, it is the power customer use. For example, if you use 5 kilowatt load, we will discharge 5 kilowatt. But when you discharge, the SOC goes down here, then it enters peak shaving mode again. And then in the peak shaving mode, then we have to avoid using too much power from the utility. So we will only compensate the difference one. For example, peak shaving is 15 kilowatt and you have 20 kilowatt load. Then we will compensate 5 kilowatt to avoid using too much power from the utility. So this is peak shaving. I can show the example later. Then next one is AC charge. AC charge is like you have the AC to charge the battery, and if you have solar, the solar can charge battery together. For AC charge setting, and also that we have backup mode in our system, it is similar to AC charge, because in backup mode, we will use AC to charge the battery to keep a higher battery SOC in case there is like load shedding. For AC charge, we need to set the AC charge power and AC charge time, because customer may only want, in some countries, customer may only want to charge the battery at low cost in the midnight. So he can choose when to charge the battery and what is the power to charge the battery. And also what is the end SOC to charge the battery. Then the last one is forced discharge. Forced discharge is like in the application first, you can sell to the grid. So actually in the UK market, we can get the power cost from the power company. And when we find the selling price is higher, then we can sell the power from the battery to the grid. And when we get buying power energy cost is low, then we buying from the grid. So it's like buying and selling the power according to the price. In this situation, you may use forced discharge function. And in another application is when installer install the system at the site, you want to do some test because maybe that time the load is not enough. You want like full discharge to see make sure all the installation connections are right. Then in this situation, you can set forced discharge to see if you can set AC charge to see if charge is okay, and you can set forced discharge to see if the forced discharge is okay, and then it helps you to verify the installation. So that's the introduction for the working modes. The self-consumption mode is like you use the energy, you use the solar, you use the battery energy and try to avoid using energy from the utility. And for the charge first mode, it's like you want to charge your battery first because maybe later you will have load shedding. So you always want your battery keep in a certain percentage for future use. Peak shaving is like you have limitation from the utility. Otherwise, you have to pay higher cost for your power. Then in this situation, you will use peak shaving. And the AC charge is like first, you want to back up your battery. And the second, you may want to test the system. Then also that in some period, the time in the midnight, the power cost is low. And then you may want to use the AC charge to charge your battery when the power cost is low. This is the application for the AC charge. At last is forced discharge, as mentioned. Then maybe because of the selling price is high, you can sell the battery power to the grid, or after installation, you want to verify the system, then you can use forced discharge. That's the 5 working modes. Actually, for one inverter, you can set the different time for different working modes. And also, this is, I think, before some customer is a little bit confused on our usage for the working modes. So according to the feedback we get from the customer, we optimized the monitor system for the working mode. I will show the new monitor system page. So this is the new page. I have an inverter beside me. Is a 12 kilowatt Europe version inverter. So here is the new working mode display and settings. And then I can explain a little bit first for the new mode, working mode. Let's go back to our presentation here. Here, you can, as I showed in our monitor system, we have several working modes. We have PV charge, PV charge priority, forced discharge, and self-consumption. So actually, for this working mode, you can set the time. So for one inverter, you may have self-consumption from 1 to 9, from 0 to 9 a.m. And then you have some other working modes in other time. So customer after setting, they may like check up and down again before to say what is the setting now and what is the working mode it should be now. Then it's a little bit difficult for the customer. So we combine all the working information in this picture. And so for this line, active mode, for the first line, you can see that after setting, from the second line or the customer settings, actually, then in the first line, we combine these settings, which is active in the first line. So customer can find, for example, it's 1 a.m. We can go here. Then it's like green. When green, it means self-consumption mode. So actually, for different mode, we have different colors. For this one, you can see we set PV charge priority. For example, at 10 a.m., then it's orange. It's yellow, then it's like AC charge mode. And here, customer set peak shaving, then it's peak shaving mode. So in this picture, you can see the active mode very clearly from the first line for different time. What is the working mode for different time? This is the first information you can get from this picture. And the other information I'd like to share is that you can see there are several working modes, and the customer may make some mistakes. They may set some time overlapped. For example, this is a customer setting. He set from the 10 a.m. to 3 p.m. the peak shaving. He enabled peak shaving. Meanwhile, he set from 9 a.m. to 1 p.m. AC charge. So for this period, he enabled both peak shaving and the AC charge mode. In this, if customer set like this picture, another feature is the top, when the position in this picture is higher, then the working mode priority is higher. It means that when you enable the peak shaving, all below will not take effect even if you enable it. So when it cannot take effect, then it will be a gray color. So if you disable this, there will be a orange, the whole bar will be yellow. But since you enabled peak shaving here, there are overlapped period. So in this period, the AC charge mode cannot take effect because you enabled peak shaving. Here is similar. So you can see a customer enabled both the PV charge priority for this period and also force discharge in this time. Then the PV charge priority has higher priority than the force discharge. So during this time, the PV charge will take effect. So in this picture here from the second line, you can see customer settings very clearly, and you can also know which working mode will take effect if you overlap the time you set the enabled like two modes and they have time overlapped, then the higher position will take effect. And this is the second information you can get from this picture. So it's clear what is active mode and what is the setting, which will take effect from the settings. And the other one is that for the working modes, we have for example, these two modes are conflict. Then if you enable both, only one will take effect. So the working modes for PV charge priority and AC charge can exist same time. So if you enable here and here, then it can exist same time. It means the inverter will use both PV and AC to charge the battery. Right. So this is the meaning, what information you can get from this picture. Then I can do some tests to show you how to explain what I described. Okay, we can see here, since AC charge, because from the factory, if you disable or, for example, I disable AC charge here, there is also force discharge is enabled. Let me disable it. Here, you can see for when you get the inverter from the supplier, if you do not enable any working modes, it from the factory, it will be like all self-consumption mode. And after you get it, you may do some modification, change some settings. For example, now you see, if I enable, not sure if we have to set standby. Let me try to set standby to see if we can enable the backup function. Still can't set. So I will figure out why it cannot enable backup mode later. Then, for example, we can set peak shaving. Let's try here. we enabled the peak shaving, but we didn't set the time. So we can set from the start to end, for example, the time. Okay, then you can see that with enabled peak shaving, we can set 5 kilowatt here. Then say when we enable peak shaving, we need to set the peak shaving power and the period for peak shaving. We set from 0 to 12 kilowatt. 12 a.m. Then so for this byte will be purple because we enabled peak shaving, and then the left will be self-consumption. Then let's see if we enable AC charge. So there are some time we can, for example, so you can see now it's from the almost 0 to 11 p.m. So the whole bar from here to here is like orange, and so this, because we already enable peak shaving and it has higher priority, so this bar goes to gray, and if we disable this one, so you can see the whole bar will be orange one, and if we change the time, so after we change the time, you can see the active mode where this bar will change according to your settings. Then PV charge priority is similar. You can enable the PV charge function, and you can set the charge first power. For example, if you set 3 kilowatt and from as charge first power, and you have 6 kilowatt from the solar panel, then the extra 3 kilowatt will go to the load. And you also need to set the time for charge first. And this is forced discharge. There is another function for export PV only. It means that if you have, because in some country, you can only sell the solar power to the grid. You cannot sell the battery power to the grid. So if you enable this, the solar panel power, for example, 5 kilowatt, you have 5 kilowatt solar power, it will sell to grid. And this time you have 3 kilowatt, for example, load, and the battery will take 3 kilowatt load. So you can sell much more power as the solar power to the grid, and the battery discharge to take the load. That is export PV only. Then we can do some tests. For example, maybe let's test the AC charge. So we enable here, and we have AC charge because now it's according to time. According to time, the voltage, stop AC charge voltage, I think is set controlled by voltage. So the voltage there is active. So here, because we charge according to voltage, we can charge according to SOC. Okay. We can set here stop as we can see what is the system now, status now. We can take it to normal. So now we are doing some test, show some example of our inverter. Let's see what is the working mode. Let's see what is the setting. Now is 5. So now it should be in self-consumption mode. In self-consumption mode, the inverter will, battery will take the load. Solar and the battery will take the load, and the inverter will not use the power from the utility. So let's see. Sorry, it's not this one beside me. Okay, this is the inverter here. We have 100%, and I haven't take any load, so we can take some load. So now we have 3 kilowatt. We can show the system. Okay, so we are in the meeting room and we have inverter here. So now we can see that we are taking 3 kilowatt from the taking load because the battery will discharge. Needs time to detect the load. Just now it was in standby, so we can see here in the self-consumption mode. Now there is no solar. I didn't connect the solar input, so it's just battery. And in this situation, in the self-consumption mode, the battery will take the load. And yes, so this is the LCD display. We can go to our monitor system. Okay, see, we have 5 kilowatt at the load side. So the battery is discharging to take the load, and we can see the information here. So we can have battery 1 and the battery 2 module, all the detailed information. And this is in self-consumption mode. Okay, and then let's see our working mode here. So you click here to get the new page, new display for the monitor system. Now we can change to another working mode. For example, it was self-consumption mode. If I enable like AC charge mode, then it will use AC charge. We can enable charge priority. So here we enable charge priority. Now the time is for, we can set here. Oh, okay. So now then you can see it's almost 5 p.m. here, and now 5 p.m. is the orange color and it's charge first. So as mentioned in charge first mode, if there is solar will charge the battery first and then take the load. But now we haven't connected the solar, so there is no solar, but it's still discharged. Let's see. So we can check our settings. So it's PV charge priority. And let's see the setting. Stop is 100. We haven't get the update from the monitor system, but we can see from the LCD, it already use the AC to take the load. We can see once after I enabled the charge priority, the battery will not discharge, and then the utility will take the load, because we think in charge first or charge priority mode, we need to keep the battery in a certain SOC percentage. So in this situation, we will not discharge from the battery. When there is load, we will use the utility to take the load. Okay, so we can see it's changed here. Then it's use the AC to take the load when the inverter is in charge first mode. So we go back to our working mode settings. We can disable charge first. And let's disable AC. Then in this case, when I disable or it go back to self-consumption mode, then we can test a little bit the force discharge. We can enable force discharge. So the time is already set from 0 to 11 p.m. We can force discharge like 5 kilowatt. So in this situation, now the inverter goes to force discharge mode, and it will discharge 5 kilowatt from the inverter. We can go to cases LCD. So now it's discharging from the battery. You can see the LCD. It's discharging 3.4 kilowatt. gradually it will increase the discharge power to 5 kilowatt. So it's not very clear. We can see from the, so it's 3.4 kilowatt discharge from the battery. Then let's go back to our monitor system. Okay, we go back to our monitor system. So we can see it's discharge from the battery, but the power goes to 3.4 kilowatt. Okay, so we can see the reason then it will discharge 5 kilowatt, I think. So we are setting 5 kilowatt and we enable, for example, 5 kilowatt export to the grid. Then it will force discharge 5 kilowatt. So now we can see that the discharge power from the battery is 5 kilowatt. Just now I set 5 kilowatt discharge, but it's only discharge 3.4 kilowatt because we limited the power cell to grid. So you can only discharge 3.4 kilowatt because the limitation of export. Once I let the inverter export like 5 kilowatt, then it will discharge 5 kilowatt from the battery. It's clear. So it's 5 kilowatt from battery and taking 2.4 kilowatt load and then selling 2.4 kilowatt to the grid. Then we can go to the maintenance page. So I have set do some settings and tests for the working mode. Actually, briefly summarize, it's like you can see your active mode here. According to time, you know that during which period, what is the working mode, and you can see your settings here very clearly. If you have enabled peak shaving or AC charge, and when you want to enable this setting, do some change, you click here to do some settings. And when there is conflicts, the higher position has higher priority. So you know which setting will take effect. And then I explained a little bit of the working modes. What is the like charge first, charge priority, AC charge, peak shaving, and also force discharge. So let's see if you have any questions on that. That's all from my side. Let's see if you have any questions. Okay, so someone asked the octopus charge. So octopus charge here is like, this is a power company in UK, and actually the power cost in UK is change every 30 minutes. So we will get the power cost for the next day. Then we will make the lowest as a sequence here. So for example, here 3:30 a.m. is the lowest price for you to purchase from the grid. So we make a sequence from the for the power price from low to high, and when customer can set how many periods you want when the when the power cost is low. So here you can see when you add device, you can see from 0 to 8, you can choose how many periods. So one period is 30 minutes. You can choose how many periods you want to charge the battery. For example, if you set 1, then we will use from 3:30 to 4, then AC charge the battery. So it's like charge the battery at the lowest cost. It's similar to that. So when you add device, you need to, it's for UK customer, you need to input your serial number and like in the morning, how many periods you want to charge, and from 12 to 7, how many periods you want to charge. And actually you can charge to according to the set points. It's like how many periods you want charge, and also according to price, like what is when the power cost is higher than this, we will charge the battery. When the selling price is higher than your setting, we will sell sell the power to the grid. So for you have to input your postcode because for each area, the power cost is also different. So that is Octopus. Okay, for the weather optimization here, it's like we can see. So first here, you need to add your location because the weather is different from area to area. So you have to input the location here. Then you add your inverter. You can see that there is a charge time. It means that, so for the next day, it may be sunny, there is sunshine or raining. So for example, if you can set, if there is heavy rain, you want to charge your battery in the midnight because in the midnight, the power cost is lower. So we can choose like from 0:30 to 4 a.m. when there is heavy rain, we want to charge the battery to 100%. When there is more like middle rain, we have to charge the battery at 90%. So it's like you charge your battery in the midnight according to the weather next day. If weather is raining, you can charge more power to your battery. And the next day, if the sunshine is good, then you do not need to charge in the midnight because you will have solar the next day. So it's like charge the battery according to the weather for the next day. Let's see if you have more questions. Okay, if you do not have any more questions, we can finish the webinar, and thank you for joining us. Okay, thank you, and we have recorded this webinar, and we will upload this to our YouTube. So if you want to watch it again, you can go to our YouTube to watch. And thank you again. Goodbye. I will finish the webinar. Thank you.